Problem 12.69 involves this system right here. We've got a 0.5 kilogram block B. It slides within a friction, without friction inside this slot cut in the arm OA right here, which rotates in a vertical plane. The rod has constant acceleration of theta double dot, angular acceleration of theta double dot at 10 radians per second squared. That's a counterclockwise acceleration, knowing that theta is equal that when theta is 45 degrees, r is going to be 0.8 and the velocity of the block is 0 at that point. Determine at that instant the force exerted on the block by the arm and the relative acceleration of the block with respect to the arm. So we're given theta double dots 10, at theta 45 degrees, r is 0.8 and v is equal to 0, mass is 0.5 kilograms. So A part's find the normal force, because that's the force. If you look at this object right here and do a free body diagram on it, you've got a force of gravity acting down, and then you got the arm pushing on it, and this normal force is at an angle theta. There is no friction, so that's the only forces acting on this object. I'm going to define an E sub r and E sub theta unit vector directions like that. So Newton's second law, I'm going to sum the forces in the theta direction to be equal to m times a sub theta, and what we have in the theta direction is the normal force and minus mg sine theta, the component mg that's along this direction right here. And then that's got to be equal to m times a sub theta. So n is equal to mg sine theta plus m times a sub theta. A sub theta is r theta double dot plus 2r dot theta dot. Now at 45 degrees it says that v is equal to 0, but v is also equal to r dot e sub r plus r theta dot e sub theta. Since it's 0, that means that r dot's 0, and over here theta dot would be 0 as well. So we go back over here in this expression, and the only thing that's not 0 is r theta double dot right there. So you get n equal to mg sine theta plus mr theta dot double dot. When you plug numbers in, you get 7.47 newtons. I put some little bars on the end so they didn't look the same as the normal. And at 45 degrees, and I'm going to store that number to use later, or possibly use later. It asks us in this problem to find the B part here, the relative acceleration of the block with respect to the arm. What they mean by that is if you're riding along with the arm, what do you see that block doing? And for you, what you observe is r double dot. So what we're going to do is do Newton's second law for this free body diagram, but we're going to sum the force in the r direction equal to m times a sub r. And in doing so, in the r direction, n doesn't have a component, mg does. It's mg cosine theta equal to m times a sub r. The m's would cancel out, leaving us g cosine theta equal to a sub r. But a sub r is equal to r double dot minus r theta dot squared. But you remember from before, theta dot was equal to 0 right here at that 45 degrees, and so we get that r double dot at 6.94 meters per second squared, and it's at a 45 degree angle there.